Every 4 years, we demand an answer to the same impossible question: who is going to win the World Cup? And usually, we rely on loud pundits shouting across a desk, or an opaque algorithm spitting out a definitive name with zero explanation. There is an alternative. We can build a machine learning model that actually shows its work, a system designed to quantify uncertainty rather than pretend to have a crystal ball. To evaluate any two teams, the model feeds on exactly 15 specific variables. It tracks how long players have rested. It measures squad depth using player rating estimates. It calculates historical momentum through ELO, a rolling chess-style rating system that adjusts team strength after every match. But the math carries a humbling philosophy. The system openly admits that its advantage over a basic baseline is small. Because of that, it refuses to generate a guaranteed final scoreline. This chart shows how the system predicts a match. Instead of declaring a winner, it outputs calibrated probabilities, assigning an exact percentage chance for a home win, an away win, or a draw. Then it translates the math into English. Using a technique called SHAP, which breaks down complex AI decisions, the model isolates the exact variables driving the result. It tells us precisely how much an ELO rating gap helped one team, or how a neutral venue hurt another. Establishing this honest, mathematically sound foundation for 90 minutes of football is mandatory. Once we can trust how the system sees one match, we can ask it to process a chaotic 48-team global tournament. Scaling that logic up introduces an enormous logistical problem. We have to map those individual match probabilities across a sprawling 104-game bracket. To do it, we use a Monte Carlo simulation. This engine is programmed with the official 2026 World Cup rules, allowing it to navigate the complex pathways from the group stage to the final. The simulation does not automatically advance the statistical favorite. Instead, it rolls virtual dice weighted bar match probabilities, ensuring that upsets happen exactly as often as the math suggests they should. But pure probability has to bend to reality. 44 matches in this tournament have already been played. This chart shows the current group stage standings. We lock in those 44 completed results permanently. The engine treats them as absolute facts, meaning it only simulates the matches that haven't happened yet. International football is a high-variance sport. A single bounce of the ball can rewrite the bracket. Running this simulation one time just gives us a single thread of statistical noise. So we hit run 1 million times. The probabilities exhaustively cascade through the schedule, mapping out every mathematically viable timeline. By forcing 1 million probabilistic futures through the bottleneck of immutable real-world results, we stop guessing as the most frequent champion, lifting the trophy in 30.8% of the simulations. Trailing directly behind them is the only other overwhelming heavyweight, Argentina, taking the title nearly 19% of the time. Why do these two specific rosters hoard nearly half of all million outcomes? This chart shows the projected bracket geometry. The official draw physically separates them. Because Spain and Argentina sit on opposite halves of the board, they are mathematically protected from eliminating each other until the final. Yet this same bracket geometry dictates the fates of the statistical anomalies, giving lesser teams a structured path to outrun their own probabilities. This chart reveals the deepest underdog runs in the simulation. The United States ranks 24th in raw strength, yet the math puts them in the quarterfinals 43% of the time. 3 realities dictate that run. They banked early wins in the group stage, they operate with a measurable home field advantage, and their slot in the draw shields them from top-tier opponents in early knockout rounds. We are left with a paradox. The millions of simulations declare Spain the overwhelming statistical favorite. At the exact same time, the data proves that Spain will fail to win 69% of the time. An honest predictive system doesn't try to hand you false certainty. It quantifies the chaos, showing us precisely how many improbable ways the future can still unfold.